Hey, good afternoon everyone. Welcome back to my channel. Thank you for all the nice comments and the private messages we received. Really appreciate it. Today is Wednesday. We are working on to continue with the GPIO side. Initially, a couple of videos ago, I've done the GPIO output bit, whereas we picked up the pins, found out which pin we need to write to, and then wrote the, as you can see, wrote on the LEDs, as you can see on my screen here on the middle. And then the next video we did threads and tasks and sysbios, and rather than doing it as an input. The reason, because in the input today, it's really important for you to understand how the sysbios works and the task and thread, because you're going to run task and thread just to read the pins from the system, and also we'll have the other mode as well. So just without further ado, rather than taking time, just a quick brief on this. The input we're going to read today two different ways. We're going to read from something called the polling mode, whereas we have a loop in the background as a task running, or thread in PC's world. It will keep looping and then check if we have the pin set to read, or so if it has data coming on the pin, and we use the pin data this way. It's not recommended. I don't like reading things on a polling mode, because there's all sorts of reasons. You could be reading the 0 twice or the 1 twice, etc. But on the other side, we're going to also do today is the interrupt mode. Interrupt means only you'll get notified when there's data moved on the pin. So if a 0 is moved, shoved in twice, you should get 2 interrupts at some point. Not 100% true or always true, but also with the timing and all configuration and synchronization. But for now, I think just to get going, we'll carry on working on the GPIO input side, and hopefully we'll take it from there. So let's just jump into the development screen, and here's where we left things off. So right now we have the serial UART is kind of chucking stuff quite rapidly, and that's not something we're going to be able to read easily. And what we'll do now is, as you can see, we have GPIO. We're toggling all 4 pins at the same time, and we are delaying by 200, or the fifth of a second, and then we are going to loop forever. So that what we need to do right now is, I'll put that dot in there, which is this these dots in here, so that makes the line kind of consistent. And the second thread, a second task, we have the LED ripple in there, and frankly I don't want to ripple that off, so I don't want to kind of cause, so what that means is we're disabling this task from rippling the LEDs, and only this LED is going to just flick back and forth. And what I'm doing as well in here, I'm going to increase the timeout to 1 second instead. I think I like that more, just to be consistent. Just really nicely compiling stuff now, and then see how this is going to go. So we expect to see almost no logs, it's just about a couple of lines, and then only 1 second each light switching off. So we're just looking at the screen in here just to see the lights now going crazy. They should be just 1 second on, 1 second off. Yeah, there we go. So now we go. So go on, off, perfect, exactly how you want it. Also, the only line we're displaying is this LED toggle loop start. So clear the screen, and that's pretty much what you want. And what I'll do now, I will create another thread. So if I'm gonna just duplicate this bit in here with the for loop, and task toggle, let's just say in here, I'm just going to shut that down and shut that down. Right, so what I'm doing, task, I'm going to say switch read. Yeah. And I'm going to say here yeah, that's pretty much it. So if what I will do here is if, or before I do the if and then, let's just put this into the tasks. So I'm now going back into SysBIOS, adding onto threads. You can see here. Let's just go into SysBIOS scheduling to end the task. Let me just take you back in slow motion. So SysBIOS, you click on task. Sorry, click on the system overview on here, and then task, and then you got the instance in here. So module will display this bit, and instance is this part. So you need to add a new task. Yeah, so a new task is added, and the function, obviously, as you can see, and we'll just call it switch read, or read like that. That's it, that's all to it. So if I save, this now should start a new task or a new thread. Just waiting for it to save and update. Shouldn't take long. Good, okay. So now we're back in here. So if I run the system now, it will just enter a very, there's no delay on here, so that's going to be a pretty heavy loop. So what I'll do now, we're getting into a stage whereas using the pin numbers or the indexes within the array as numbers is going to get quite messy. You end up in a spaghetti junction. In 6 months time you open up the code not knowing what that 0 means and that sort of stuff. So what we need to do really is start moving on to calling them names, just naming the pins as opposed to calling them something. So here you can obviously just say output LED 0 if you want to, and so on. Yeah, but so 2 and 3, or let's just say 1, 2, 3, 4. Let's just call them LED. So what we'll do now, we'll start define LED versus GPIO LED 1 as 0. That 0 is the index location, which is this bit here. Yeah. LED 2, 3 and 4. Yeah. Bear with me here. What I'm doing now is I'm just calling them LED 1, 2 and 3 and 4. So if I were to just see where did I do GPIO stuff, and that's all fine. That's all good. Yeah, this bit I don't think we should do like that. So LED ripple, I'm pretty much going to get rid of that function at some point, but rather than doing a for loop in here, what we'll do instead, we'll just say GPIO. Yeah, so we'll do GPIO LED 1, comma 1. Yeah, so there's only 4 LEDs. We switch them all on here, rather than having this into this you know, array stuff. Yeah, and to be honest with you, I don't want to have 4 lines that says switching them on. We can just say now switching. Yeah, so let's just make it into a 1 0 1 0, and the other bit is going to be 0 1 0 1. So 0 1 0, sorry, 0 1. Just to alternate them. So now switching LEDs. LEDs 1 and 3. Just keep it simple. Now switching on the LEDs 2 and 4. That's it. Now all that stuff I will just take out and delete. Yeah, there's a delay. We need to keep that there. So delay of half a millisecond here, and then delay. Let's keep it the same. I like it to look like an aircraft. So this GPIO delay will do exactly that. So these two. Yeah. An LED flash, LED ripple, that's fine. LED toggle. Yeah, so I mean this is all fine. So now, just to double check. So now we have the LED, instead of calling it 0 or 1 or 2 and 3, we're just naming it there. So here we are doing LED 1, LED 2, LED 3, and just bear with me, you'll see why that is. So now we are toggling all these 4 LEDs, and I think on the main side we also need to kind of look for that to see where are they. Where's my main gone? Oh, I see. So we did the ripple. I see. That's fine. Yeah. BIOS starts. So take these off. We know these are not going to work, and move those here. LED ripple once. Yeah. So we're rippling it off once, and then we start on the BIOS. Good. So ripple will. Exactly. So ripple will kind of do 1 0 1 0 and then 0 1 0 1. But actually I can't do it like this. So oh, you know what? I don't like this. You know, I want to do this ripple instead of the other loop. So rather than toggling here, I'm just going to do. Let me see. Can I do LED? Is the LED ripple looping? Yeah. So I'll do, rather than having it like this, get rid of that, and I'll do LED ripple instead. So here it will be you know, 1 0 1 0 0 1 0 1. That's what I want. And the task switch read, yeah, so we're reading the switch in here. Right. Now, what I want to do, let me just put a little delay on that side. just for the hell of it, this is nothing going to happen in here. We're just going to see the this is starting that loop, and that's it. What I want to do is, what I'm hoping to see is when I run this again, it should have everything, you know, up and running, and LEDs all functioning as we want them to. So they'll go like this and that, and we'll see how that's going to go. So it's really important to get this step right, because now in a minute you'll see why when we're going to toggle, you know, to tweak the arrays and then carry on this way. Now notice the lights are all on and off 1 second apart. Come on. I think it's just this BIOS bit. It's kind of doing the changes there. You can always skip by pressing the right arrow key for 10 seconds rather than waiting for this thing to finish. Yeah, we're linking now, so it's good. There we go. I might actually speed this up. I don't like it's taking too long. Yeah, build finish, quite good. So now we're launching. So now the lights should go 1, 3 and then 2, 4, 1, 3, 2, 4, that sort of thing. It looks like number 3 isn't working. And that's, you see, this is what I wanted to verify. This should work, but because there's something not right. Let's have a look and see why. There we go. So this is the problem. All of them are saying 0. So this should be 0, 1, 2, and 3. Is the index within the array. So that's why so 0, 1, 2, 3. That's it. So now let's try again. I should be quick now because we already run this BIOS bit and done the compilation, so that shouldn't take long. we should see the lights outputting the one as we want. There we go, exactly. So now you see, if we look at the board, so 1, 3 and then 2 and 4. That's exactly what we want to have in here, right? So now here is why we've done this. You might think this is a waste of time, but actually it's not. It really is a very, very important and crucial step. What we need to do, because we have a callback function, the callback function usually will take one argument per, or one, let's call it an interrupt per entry. So if you wanted to say, I want to, my function XYZ to be called, you just put XYZ in here. But because this XYZ at the beginning, it's going to call this one on the output pin, because it's the first item in the index. First index in the array. And if you wanted to do the third one, like this one here, you're going to have to do null, null, and then like this. Sorry, null, and like that, right? But it's not a good common practice. Even with TI, they actually recommend you to, the documentation and stuff, they say try to keep the ones with interrupt at the beginning and the ones that you're going to output for, or not really have interrupts on at the end, which makes total sense. So now, here is why we did all this stuff. So if I'm now going to say, I'm going to insert, not add, I'm going to insert pin number 33 as GPIO input. Yeah, and just looking into the GPIO side, so I go to the includes and PDK. We've done this before, but I'll just recap because I wanted to have that set to pull up, and I'll take you through where to set these things up from. So input, and we are looking for DRV GPIO and then GPIO.h. So this guy should really tells us input and output and all that kind of stuff. So now we're looking for is input, is what we just did, and I want to have that as a falling pulse or rising pulse. We got to do rising because I want when the user releases the button to get it. But to be honest, it's not going to matter in here. Let's just do rising. They help me on this. Falling means when the signal falls is what TI recommends for the buttons, for the switches. But well, let's do falling. Let's do falling. Let's just take it from there. You'll see the difference. So if I go back in here and I'm going to OR this with the falling side, and this is now going to be called input LED 1. Right. One more thing I wanted to share with you as well. Where's the document gone? Nope. Nope. No. Not this. Should be one of those two. I think it's that one. Yes, there we go. Okay. Where are we? We're here down there. I'm looking for the table just to show. Yes, exactly. Okay. So this is the OMAP reference, or not a reference. This is a quick. What's the document called? This is the LCDK user's guide. It's a very short document, it's about 15 pages. I think it's pretty much one of the most important documents, to be honest with you, because it tells you more about the hardware than the others. The others kind of focus on the development side or the reference manual. So this will tell you what things, making up that development board, the LCDK. So you got the video DAC, you got the the audio codec, you got a lot of stuff happening in here. Currently we're going to work on the GPIO at the moment. So for the sake of this video, This is the board, by the way. That's what it's got, and we kind of touched on video 1. This where's it gone? GPIO 01. Yes, there we go. Okay. So on this side, you are looking at the reference document, and if you remember in the past, we worked on the LEDs, right? Now, if you look at the LED section that we have over here, we did 9, 44, 108, and 109, and if you remember, when we did them before, we kind of did the hard way to work out where the LEDs are. But the document in here, after lots and lots of research, I realized, well, I found the document to begin with, and now you see things like that. So GPIO 6 of 13. When you read that, you wonder, that doesn't mean any, much, or it doesn't really help me to kind of convert that into number. But just to help you to convert it to number, usually anything, I did say this in video 1, I think, or video 3. Usually you take the number in here, so just after the GPIO, so number 6, okay, and you multiply that by 16, because every bank has got, sorry, every bank has got 16 IOs or GPIOs, and then you add this one to them, and that's how you end up in the pin number. So what happens is, let's just look at this one, run the calculator, and if I take the calculator in here and say, for example, 6 times 16 plus 13 is 109. So this is the first pin that we have on that side. So this is where 109 comes from. 108 is the one next to it, and then 44 and 9 in the same way. Yeah. So the switch we are talking about is 204 and 205. So 2, where's the calculator gone? Calculator, where's it gone? Yeah, there we are. Right. So 2 times 16 is 32, obviously, plus 4 is 36. So 36 and 37 are the switch for the pins. We're not interested in the reset one. What we're interested in is just the go away. We're interested in pretty much these S2 and S3, right? So what did we say? We said it's 36 and 37, right? So here we're doing 36 and 37. Yeah. So now we have the 2 pins coming up on that side, which means indexes 0, 1 are no longer valid for our LEDs. So the LEDs should start from 2, 3, 4, 5. Yeah. So here, what we're going to do, and this is the important part. That's exactly what I was talking about now. So now we move the whole array. The whole array, we inserted 2 elements, and these now can all shifted down. So if I had this as zeros, 0, 1, 2, 3 in the code everywhere, hard coded to numbers, that means I have to go to every single line in the code and change the 0 into 2 and 1 into 3 and so on. But now this is how easy it is, because I'm referencing, the in the name as opposed to the number. I can just say now, so 0, 1, 2, 3, 4, 5, and now I'm going to define 2 more pins, and I'm going to say GPIO SW2 and SW3, and these are going to be my 0 and 1, right? So when I'm referencing this, SW2 is actually, let's just call them SW1 and 2, why not? Yeah, 1 and 2, because 3 we never use, it's just a reset button, so I'd rather just, be consistent. My switch is 1 and 2, although it's got 2 and 3 on the board, I don't care. So now we're going down the loop and back onto the task switch read, yeah, and I'm going to say, let's just say if GPIO read off. What switch we are doing? So GPIO, we did SW1. If that becomes a 0, which is pulled down, then I want you to tell me about it. Actually, before I carry on this way, I want to show you something. I want to show you something bad before it happens. So printf switch 1, sorry. Let's just SW1 has been triggered. Yeah. And this one, I will actually wanted to. I would like to delay that for a bit. So I'm going to say delay by half a second is fine. Yeah. And on the other bit is similar to this bit here. So if I read GPIO switch 2 becomes 0, then I would say switch 2 has been triggered, and I'll wait for half a second. Yeah. So notice if I'm waiting here and someone pressed that button, that's the downside of this code. If I'm waiting here and someone pressed that down, this may not work until after half a millisecond, which is why the polling mode isn't really great. So let's just power this up, take it from there. So notice we are using printf, and you'll see what happens. Printf is like the bread and butter of C. When you use printf, you are usually, it's like the most basic function that you use, or the most initial element, or stepstone. It's like system out printing in Java, and it's like NSLog in Apple. It should just work, but because it's using the debugger interface and the USB, it's difficult for it to actually keep up, and you'll see that in a minute. I should have waited for this to finish. So here we go. So now we have the switch started. Let's just clear the screen for a bit. And if I press the switches, if I press switch 1, see that? So now we are reading in polling mode. You see this? Let me increase the size of the screen and enable this bit on. So if I press the screen in here, and actually I would like to move you on that side. Yes, thank you. That's easier. Yeah. And if I press this switch now, if I can see it, yeah. See that? So now the switch is now working fine. Do you see the problem? I don't think you do see the problem. The problem is printf is doing a bugger all. It's doing nothing. Yeah? I beg your pardon. When I press the switch key, let me just reset the thingy, clear screen. And I press the... Yeah, sorry. What am I doing? What am I talking about? Yeah, this is the problem. When I press the button, it says now switching LED 2 and 4. Yeah, so it's not saying switch 1 has been triggered in here, and it's not saying switch 2 has been triggered, as if the whole system kind of halted or stopped, or there's something wrong with it, something terribly wrong. So if I press again any of the buttons, it's like all the tasks now kind of stopped and waiting for that switch to work. So, you're thinking, what the heck's going on? This is not really, what I signed up for. That's not really right. And before you even know it, and also, sorry, to up for that, the bigger problem is we're not seeing any output here. So this, we know this worked for a bit because it did say switch loop reader started, but and we know we're in infinite loop because there's nothing should break this off. But the problem is we're not seeing this outputting in here. And we know system main started is working because it did say system main started on printf. But the problem is, in tasks, when you use printf, you are killing your system badly. So this is a tip for you. Do not use printf you know, in tasks and threads and interrupts. Never use printf. It's very heavy and it will cause up big problems. So UART, add that in there instead. And I've done that intentionally just to show you what happens. And notice when I clicked any switches, nothing happened. But you can see when I click in, it's trying to do something, so I'm not going to recompile again. And now you'll see the difference. And this is also another thing about polling mode. Polling mode, it'll just go into a loop. So in here, polling mode is just looping up. And that loop does cost cycles on the CPU. So just going to keep, if you know, it's not a nightmare, but it's really a bad way of coding, to be honest with you. You really don't want to have, you know, loop going on like this, because if that thing comes up without this delay, you could be reading that bit twice, or maybe, you know, 100 times, saying 0 by having that one click. So I just wanted to carry on and reach that point where we see something. See, also the LEDs on the screen aren't really updating. So let's see. Where we are now, switch reader started, and we are not. Hold on. UART working on serial now, good. LED toggle loop started. Which is LED toggle loop started. Yeah, and that's the ripple side here, and this is fine. And this is the bit that should go left and right. So let's just see the LED, the toggle bit. So that should be fine. Delay, yeah, that should work fine, no problem. And switch reader loop started. Where is switch reader? So switch reader is good. GPIO, if GPIO read is 0, then it's been triggered. If GPIO read is 0, then it's not triggered. The problem I'm seeing is I'm not really seeing the loop carrying on. I don't know what's going on. Let me restart without let me just disable this whole loop thing, just to see. I just need to see the light starting. Unless printf did something wrong to the board, and we'll have to restart the board instead. We'll see. In the worst case, I'll just restart the board and then take it from there. But I'd expect to see the lights to come on. Yeah, so the lights are on. Good, that's what we want. That's very good. and that for loop is there. If that is, let's just enable it again. Yeah, if this, then print that. Just out of interest, I'm a bit feeling silly about this. Let's just say pin data, and I would say pin data equals we're reading it there, and then we do in pin data equals switch 2. And if pin data is 0, then display something. And that's pretty much what I want to do. So first it will read SW1, do some logic, and then read SW2. Out of interest, let me just put a little delay, just in case this thing is taking a long time and causing the salting to choke. Let's do it this way. Let's do a delay of, 50, which should allow the system to breathe. View the screen. Okay, so here we have it. Now we have the thingy working fine. So now we've seen the loop, we've seen the LEDs flashing, flashing. And if I press the switch, see that? Now I'm pressing it, switch 1. What am I saying? Switch 2, yeah, that's switch 2. Now let's see switch 1. Switch 1, here we go. So now it's working. So now we have the system running, and it's exactly doing what we want. So it's kind of, we're listening on the pins, we are toggling the stuff, and actually I don't, if I wanted to do stuff like that, so if I can just do GPIO toggle, let's do GPIO LED 1 and LED 2, and in here I will do LED 3 and 4. So this makes it more interesting, just to show me visually on the board that what I want to do. So just sorry if I was typing in the small window. What I've done is I've said the UART printf, just after the UART printf, I said toggle pin 1 and 2, and if I press the other switch, toggle 3 and 4. It's really basic, really simple. So if I'm gonna go into the board again, just waiting for that to load. In case you missed it, pin data, we're reading it into a variable. So switch 1 is going to pin data, and then we're checking on pin data, and then doing it this way. Yeah. Right. So let's look into this one here. And if I press the switch now, so switch 1, notice the LEDs. It's switch 1 is doing 1 and 2. See that? And switch 2 switch 1 is doing the opposite way. See that? If I press them together, or one after the other, you can see now the rhythm is kind of disturbed. Yeah. So now you see this is working, yes, but it's not great because of these delays and all that kind of stuff. It's it's really bad practice. It's not really good way of doing interrupts. If you have a hardware device running at at 400 megabit per second, that's the worst thing you can do. It's just a complete nightmare. So the way to solve this is to start using interrupts. Now, so far, I think with all the modifications we've added to the system, and this is the point of building it from the first place, from scratch, to get that far. Now we have a GPIO outputs on pin 1, 2, 3, 4. We can tell it what to do. We can, draw any pin we like, and now also we have a switch 1 and switch 2 and 3. I'm calling it 1 and 2. To read the stuff we want to read, and then interface or kind of output things this way. So it's all good so far, and then we're going to add the interrupt on top, and this is why my videos are taking slightly longer time, because we are building it from scratch. And this is for you if you want to work on Texas Instruments devices like the OMAP, like the AM5728. Honestly, with using my videos, you should just get you there, and you should be able to develop and deploy whatever you want. And hopefully they should be helpful to you at some point. So anyway, we'll carry on. And the second type of things, we're not going to read. In fact, we're going to disable this whole loop altogether. So now, rather than having it there, I'm just going to say return, which means this code, the code below will not work, will not execute unless return. So the execute for now. What that means is return will exit the function. Will not, that whole thing will no longer work. So if I want to switch it, read, press the buttons, will do nothing from now on. I don't want to verify it. There's no point. It will, because we're trying to save on compilation time. So now back into the where we all started. So remember what we did. We have 36 and 37, which is I'm calling it switch 1. And switch 2, right? Now we have everything as we want. LEDs and switches, they're all there. Wonderful. Now the bit that we are missing so far is this guy here. So what we need to do, I need to start saying to it, because I want the first item in the array, this guy here, if someone presses that, to do something here. So what that means is I would like to create a function. Let's just copy stuff from here. Let's say, for the argument's sake, let's just go and say void sw1, or let's just say ISR stands for interrupt service request. ISR is as an interrupt. ISR SW1 or SO beat button SW1. Well, we know it's pressed. Void. Yeah. And now all I have to do is, rather than having all this delays and all that crap, is just to say printf. I'll just do a toggle. I'll do a printf actually. No delay, just like that. So notice in here, and I'm going to say SWR ISR SW1. I don't want to say how it's been triggered and stuff. So ISR interrupt request SW1, and I'll toggle these two. Yeah, and I'm going to say another function SW2 instead, and I'm calling it SW2, and I'm going to toggle LED. Actually, you know, LED 1 and 2, let's just do 1 and 3, or 1 and 4 actually, and then here we'll do 2 and 3, just to make it different than the original. So now notice we have ISR button SW 1 and 2. So this is 1 and this is 2. What we'll do here, we're going back to the array rather than calling this nil. So SW1 and SW2. In theory, if I run the code now and press the SW1 or 2 button, I should have an ISR triggered onto these two guys, right? But let's see what happens now. And here is the bit that gets quite interesting, and a lot of people online don't really understand. They're doing this bit and there's still nothing, no triggering, no interrupt being triggered whatsoever. Another bit as well, we got an error by the way, and I think I know what it is. So yeah, stop. What that means is, okay, so now this guy does not know who SW1 is. Because this is on top and the function is at the bottom, the C will not read it. It's not like Objective-C or Cocoa Touch or Visual Basic or Visual Studio or C++. These don't, well, no, it should be called object-oriented. Should be object-oriented. But the object, because it's at the bottom, the system will not see it. The solution is to take the function header, take these two guys, so this one, and then paste it in here. So before the define, after the define, so we're doing it there, just literally. So that's one. Just to say to the system, just be aware that we have two functions defined below. So that should just get these guys to work at least for now. So if I recompile again, let's stop this guy. If I go back and compile again, I'll ask it to run again, the error should just go away. But still, don't count too much on this. You'll see why in a minute. Yeah, the moment of truth is just clear the screen here and the scroll block. Right, okay, so now we're back online, running the new code. Is that indexing? What is this doing? Yeah, it should be running. So if I press the buttons now, nothing happening. Yeah. Sorry, it looks like I developed the stuff and my screen was on the small one. I keep doing that, I don't know why. I know, just take you back to what I did, just to carry on, sorry, from there. What we did, I have created, just in case the screen was a bit small, I've created two functions, just like that, okay? Void input and void output, right? So void output, I beg your pardon. And the function just have three lines. One that says print SW1 being pressed from the ISR, and toggle LED 1 and 4, and switch 2 if it's got pressed, or if that function gets hit. SW2 here is being printed to there, and the LED 2 and 3 will get toggled, right? And on the top side, what we said, we copied the let's just go back in here again, sorry. We copied this baby here, we copied that and that, we copied those two, and we pasted them in here like that with a semicolon at the end each. So this will tell the system we have something down there. So just look for this underneath. And what we say into the system, if with the callback, set them up as SW1. So if someone press SW1, it should just call this function here, which is down there. And if someone press S2, or the second index in the array, then do the same thing. So that should in theory work, but actually is not. Another bit that might get into your mind is the init GPIO. Now, documentation said you need to enable the interrupt. So what happens is after you reset the GPIO, so GPIO enable interrupt on pin number GPIO SW1, and we enable the interrupt on GPIO. I think it's called enable int. That's why it's not pink. Enable, there we go. So enable int on both these guys, right? And if we run again now, it'll still not be a happy ending yet. You'll see why in a minute. We're nearly done. I just wanted to take you through this. 58 minutes. I don't know if we can make this in one hour. I don't know. We might. Very good, nearly there. Okay, so now you're running the new version of the code. If I press the buttons, nothing happening. Nothing happening, absolutely nothing. And this is the bit that a lot of people got really cheesed off about, and they're thinking, what is going on? I've enabled the interrupt, I've configured the GPIO, I've done all this stuff, I've got all the functions up and running, everything is defined, blah blah blah, but it's just not working. Now also on the other bit, I just wanted to delay that more a bit, rather than half a second, let's just do 1 second each. So 1000, 1000, yeah, okay. And yeah, it's just not a happy ending. If you notice, just to take you through the mechanics, these two guys are input type and they are on the falling edge, and therefore they should trigger an interrupt. These guys are output pins, the LEDs we defined. These are the functions that we should hit when you press SW1 and SW2. and these are the interrupts for them, just to say button 1 goes here, button 2 goes there. And we did define these things as the array says, and the v0 configuration as per the first video. We leave in the priority as 0, don't worry about that yet. We're initializing the GPIO nicely, we're enabling the interrupts nicely. So why is it not working? And the answer is, and this is something I actually found the hard way. Not really much documentation on it, but it's something you really need to enable the bank for it. So GPIO, and then you do sock set bank interrupt to, you do the bank itself and the GPIO, so you do a 36U. And this is the code for switch 2. So you can just choose any pin in there. That's absolutely fine. The most important part is this bit here. So this is the bank number, and you have to get this right. This is where your documentation will say. In general, it's pretty much almost 0 in most of the boards. There are things like on a different bank. It'll be C0 and stuff, but for now just use for 0, and or refer to your BIOS documentation for more information. So 36U, and you can have a nil in here. That doesn't matter, because what happens is you're going to be enabling them. That nil basically means the function that you'd like this interrupt to be set to. But we already set this up in the arrays. So if I run this again now. And that was just the one line. This is just the thingy itself. Let's just clear the screen, clear the scroll block. It should be 1 second each. There we go. So now we are up and running. Let's just look at the bigger screen. And if I press switch 1, see that? I'm now getting interrupt. And if I press it more and more, see that? ISR. By the way, if I press and hold, it's giving me something. Release is giving me something else. This bit also, same thing. Where is it? Yeah. Notice when I'm triggering, notice the LED lights. They're going left and right, and on that side they're going 2 and 3. So, if I can also press them together actually, like that, and it will still run absolutely fine. So, as you can see now, what we did is all to do with this line here. There's a lot of people have no idea how this works, and that hopefully should really help you out. What you need to do is set the bank interrupt to whatever, just say that this will allow the interrupt on the whole bank, and then from there you can tell the system to enable or disable interrupt if you like, or set this thing to GPIO. There's another function in case you don't like to do this here, you like to do this programmatically. Let's say this you don't allow now here, just in case you don't allow it there. What am I talking about this? Yeah, so nil, you're not allowing it there, right? But you do like to allow it, say for some reason you want to do it later on the development side, and I'll show you that how. I'll show you how that in a minute. So there we go. before you enable the interrupt, you have to tell the system to set callback. So GPIO, should get it done properly. GPIO set callback into so that the button that you need. Sorry, the button that you need is going to be GPIO SW2, we said, and that should go to this guy. And it's really, I think that should be called back like that. There we go. Good. So switch 2 is going to ISR button switch 2. So it's just let me show you if I don't do this and I don't enable interrupt on the second one here. So now only switch 1 should work, and I'll show you that now. So if I run right, okay, so now you're back online. And I thought I changed this to 1 second. Why is it still half a millisecond, half a second now? Did I do the wrong one? Yeah, the ripple is still half a millisecond. It should be 1. 1 here, and 1 there. I wanted it slower, so that's fine. Maybe I've done the, yeah, anyway, I've done the wrong function. That doesn't matter. Right, so if I press function 2, see, nothing happened. Let's just put it on the big screen. Nothing. If I press switch 1, I'm not doing the LEDs. So now we know switch 2 works and switch 1 doesn't. Sorry, switch 1 works and switch 2 doesn't. To fix the problem, or to get back into the stuff, we will just say set the callback in here and enable the interrupt on that one. And if I run this now, so now programmatically I'm telling it, if anyone press switch 2, chuck it down to switch 2 there, here, and then enable that. So that's how you can enable and disable interrupt, as you go along. So we'll test this before we conclude today. I really hope you found my videos helpful. I know they're long. Sometimes when you open up YouTube and you see a video for about an hour, it's yeah, fine, whatever. But honestly, it is, I'm taking all that pain for you guys to be able to see how nice this system is or can be. I like Texas Instrument. I like the OMAP, and I do like the IM572. That the other board that I have as well, which we'll develop on it later on. But the OMAP has just been, I don't know, there's something special about it. I like it more than the 572 at the moment, even though I have all the camera and all that kind of stuff with it. So anyway, so now back to the system. I think we started, didn't we? I kind of missed that. Yeah, that's fine. So press button 1. Yeah, got it working. Press button 2, also working. Yeah, so yeah, so that whole thing works fine. And just switching back to this view here. Yeah, so this now I think the GPIO we nailed it. So we got to a stage how we read data from and how we write data to. We can read from the GPIO in loop mode or poly mode, and we can now run from the interrupt. The interrupt is really useful. I can see different to Arduino. Arduino have only one or maybe I think 5 interrupts, depending on the board. I think Mega have 5, and then the Uno have 1 or 2, I think. Anyway, but the main thing is this is the only board that does multitasking, and having two interrupts coming at the same time, like the tasks you see running, will run fine, and you can prioritize things between them, and you can do all the wonderful things like connecting to not just lights and stuff. You can just connect to all sorts of other interfaces. You can set up a clock, and the clock will drive some stuff. So I think the future, or the what's going to happen eventually with this, is we are going down we're going to have to do the USB side as well to make it into a device to talk to the PC or whatever system we're going to interface with, and I want this to output sound or audio, and what that means is we're going to use the DSP later on to set up all the functions that we need to set up to come up with sounds, FM, whatever, envelopes, and I do want to progress that further and make it into, hopefully, one day, a music instrument. So, really appreciate it. Sorry for the video, it's a bit too late. I can see it's about 1 hour and 12 minutes. I am grateful for your comments, your sharing, your liking, and your subscriptions. Thank you for that. Hopefully you find my video helpful. Other people doing the videos are charging money for it. I'm doing this for free. So this is for you. Someday you might want to design your own instrument, or just, do your own product, whatever it is. Good luck with that. So thank you for watching, and I wish you a pleasant evening. So thank you very much. Have a good evening.